So it is 10:45. I guess we'll go ahead and get started. Good morning, everyone. My name is Christopher Miller, and in case you're in the wrong room, this is for IPv6. So if you're in the wrong room, please vacate yourself. Hopefully we'll get more folks as it goes along. For the session today, some of the things that's going to be covered. A little bit of history on IP version 4 and IP version 6, how the protocols are both alike and how they're different. How you can take a look at the pitfalls of both of the protocols, some of the limitations of each, and how you can implement the new protocol which is coming out. Where you can and cannot use IPv6 today, and that includes geophysical locations as to your conference rooms, your libraries, your home, your office, that sort of thing, and also on the platforms where you can and can't use it, your operating system, your personal devices, your laptops, your computers, your workstations, your servers, etc. How the transition will likely proceed. In case you're wondering, yes, we're all going to have to go over to IPv6 eventually. So you may as well start to get your feet wet. You may as well start to learn the new protocol. It's going to behoove you to learn a bit about it now before you have to make the transition and you're stuck in an emergency and you're going, oh God, what is this? I don't understand this. I need to implement this as soon as possible. And my management, my boss, is counting on me to make it happen. So who's making the shift right now, and also who's failing behind, who's actually offering IPv6 connectivity, and what kinds of IPv6 connectivity, and who just hasn't implemented yet, and who has their heads kind of stuck in the sand like an ostrich. I'm also going to show you later on a very quick and easy method of how you can actually get IPv6 working in your home or possibly your small business if you have a few moments and a little bit of time and a little technical know-how. You can actually get IPv6 working at your office or at your home, and it's not going to cost you anything whatsoever. So a little introductions. Again, my name is Christopher Miller. I've been a Mac dude and a geek on the Macintosh platform way back in the days of System 6 and the Mac Plus. I attended Elizabethtown University near Lancaster County, Pennsylvania. I'm originally from Lancaster County. I live near Baltimore, Maryland right now in Towson, home of Black & Decker Tools. Yay! That's Towson. Towson has a little interesting history. They had a nuclear warhead pointed at it during the Cold War because we make Black & Decker tools, and the Soviets didn't want to have the tools. I only bring that up is because my wife and I are now house hunting, and just a couple of weeks ago we took a look at a house and they still have a bomb shelter in the back. It was really fun. Opened up the great big door, looked like the door to a safe. These concrete steps going 20 feet down underneath. I absolutely loved the house. I said, server room, get bombed parties, you know, poker. Wife absolutely hated it. The house is up for sale. It's going to someone else. So I'm out of server room that's bomb-proof. I currently work for Johns Hopkins University's Applied Physics Laboratory. This is a government-funded research facility. We don't have professors. We don't have classrooms. We don't have students. We don't have dorms. We don't have a hospital or a bed or surgery operating rooms. Johns Hopkins University's Applied Physics Lab was started way back in World War II when they needed to defeat the Japanese and they needed to defeat the Nazis. We developed what they call the VT fuse, or the variable timing fuse. You've all heard the rule. The only thing that close only counts in hand grenades and horseshoes. Well, there's a third piece, and that's called the VT fuse. In the Pacific Theater, when we had to fight off the Japanese and the Zeros and the kamikaze planes, a plane is a really small target from 5–10 miles out, and it's a really hard target to hit on a ship that's moving up and down on the waves. So they developed a fuse at the Applied Physics Laboratory that if you even get close to the plane, it senses it, that, hey, there's a big piece of metal nearby, I'm going to explode and throw fragments at the plane. So you didn't have to hit the plane, you just had to get really close and took down the Japanese, helped us win the war. So a little history on APL. I became interested in IPv6 several years ago when I started reading some interesting articles and journals about that we were exhausting, or at the time we were exhausting IPv4 addresses, that everyone had gone over TCP/IP, everyone had abandoned IPX and SPX and AppleTalk and the other protocols which came up and sort of died out without getting much traction. But they said, you know, we're running out of addresses here. What's actually going to become of it? So I started reading up on it, started becoming very interested in it. It's like, oh, this is an upgrade. Well, it's not really that at all. In case you're wondering, this person, the picture of Uncle Sam, is actually Vint Cerf. He is one of the founders of the Internet Standards Committee that they actually take a look at the protocols. He helped develop IPv4, and he was one of the people who helped develop IPv6. And he has been pushing for many, many years that businesses, universities, everyone needs to start converting now. They need to start getting their feet wet in this new protocol. So I'm going to use a little analogy for you. And this is courtesy of my wife's Uncle Buck. And everybody laughs and everybody giggles. If you remember the movie Uncle Buck with John Candy, no, it's not Uncle Buck. This is actually Uncle Buck. His name's Buck Clemson. He's a former aerospace engineer. He worked for General Electric. He was a contractor. He helped develop the system that tracked the Apollo capsules on their return in. He was actually on the aircraft carrier when they brought Apollo 11 back from the moon. And he is an absolute internet fan. And when I told him, hey, I'm going to be doing this talk at Penn State for the MacAdmins conference, I'm doing IPv6. He said, what in the hell is that? He said, can you explain it to a layman? He's like, I'm an aerospace engineer. I don't know what the hell you're talking about. It's okay. Oh, right. You know what? You're older, so I'll get over this with you. Remember a long time ago, Uncle Buck, when you used to pick up the telephone and you would call up your then girlfriend, now wife, and whatnot? He goes, yeah. So what was the telephone you used? And if you watch the old movies, they'll do something like, they'll pick up the phone, they'll pick up the receiver, and they'll say, operator, I need you to connect me to Lincoln 5 410 or Lincoln 5 4510, something like that. You're like, what in the hell is that? That's how the phone systems used to be working. Not everybody had a phone in the house. Eventually, everybody started developing a phone. You know, everybody used to have just one car, and you were lucky if you had one car, and you were lucky if you had a phone number. Eventually, everybody started getting a car, everybody started getting a phone. At that time, the phone system said, well, we need to do something about this because we're running out of numbers. So what they did was they converted over, they said, all right, we're going to use what they call prefix codes. And if you're probably over the age of 30, you would probably well remember that you still had the rotary dial phone perhaps, but you had to dial a 7-digit number. You dialed your prefix number, then the 4 numbers, and that was it. Your local community, your local neighborhood used the prefix code, your house with those last 4 digits. Around about 1988, 1990, 1991, they started saying, nope, we're still running out of numbers. Now you're going to have to use an area code because we're still running out of numbers. Maryland used to be all 301. The entire state was the 301 area code. Right around 1990, they actually went to 2 area codes, and it created havoc across the entire state. They had bumper stickers, they had magnets, and that sort of thing. And they eventually said, okay, we have to do the area codes. Maryland now, I think, has 6 area codes, and we're getting even more because of the explosion of cell phones, because of the explosion of fax lines, that sort of thing. And this is a great analogy for IPv6. We're running out of numbers, or rather, we're out of IP numbers in IPv4. We need to move to a new method. So, a little history of IP version 4, which you're probably somewhat familiar with, well, you're somewhat familiar with the history of, and you're familiar with how to use IPv4. Developed in the 1970s, they realized that the internet at the time was connecting a number of university and military systems. They decided that they needed a protocol for transmission control, TCP, over the internet, and they needed a protocol, IP, TCP/IP. They developed it in the 1970s, and it worked pretty well, but there were just a few boxes. Most of the time, the systems were actually connected over something called Network Control Protocol, and this is what the internet ran on up until 1983. At that point, in a single day, the entire internet switched from the Network Control Protocol over to TCP/IP in a single day because they had fewer than 1,000 hosts on the internet. So that was back in the days of Ronald Reagan. When they switched over to this, they said, God, we are set, we are good, we are really intelligent, we've got 4.3 billion addresses. God, we're never going to run out of this stuff. Boy, were they wrong. 4.3 billion. At the time, it's like, wow, someday there might be a computer in every house. Oh, God, this will be amazing. This will be fantastic. You know, computers smaller than the size of a room. Everybody will have a computer accessible in their house or maybe at their nearby library. Needless to say, they didn't realize that everybody's going to have an iPad, an iPod, an iPhone, a laptop, multiple computers, servers in their room, printers, you name it. So they figured out that 4.3 billion would probably be enough. Obviously, it's not. As time went on, the World Wide Web is developed, which opened up a GUI to basically the layman and everybody in the universe. In case you're wondering, that is the very first web server that was developed at CERN in Europe. It's actually a Steve Jobs system. Next, thank you. It's a Next computer. That was the very first server. 1992, the hosts actually generated, there were over 1 million hosts on the internet. In 1994, somewhere around the early 90s, the internet just started exploding. The web opened up, people started becoming connecting, and dial-up got much, much faster. Instead of a 300 baud modem, now you've got a full 56K modem, and you can actually do something with it. And also in 1994, registration on the internet ceased. Before that time, you could put a host on the internet, and it's fine, you could get a domain name. There was no fee attached to it. 1994, they said, no, we're going to have to charge you because we need staff to keep up with these names. So IPv4, introduced, again, in 1983. And in 1994, when everybody started coming online, they realized, you know what, this is really taking off, and we're going to be running out of numbers sometime between these dates. And it turns out they were a little conservative, but they were right. 2011, we actually ran out of numbers. In the 1990s, the birth of the dot-com bubble, all of a sudden all these businesses needed a host name, and online commerce, such as Amazon and those sorts of websites came online. Everybody could use the internet. Everybody wanted a computer. Everybody wanted to be able to buy and connect from every device that they had. 2000s, web, email, social media drives billions onto an online presence. You know, nowadays we have Facebook. 10 years ago, Facebook didn't really exist, and now everybody's on it. It's what they estimate, something like 1/5 of or 1 out of 5 people on the planet has a Facebook account right now, out of the 6.5 billion people on the globe. February 1st, 2011, the very last block of IPv4 addresses was handed out. It was bought up, and it was swallowed, and it's over. IPv4 numbers are all gobbled up. There are no more to be had. What this is creating is actually some strange things. Microsoft has a huge block of IPv4 numbers. They're actually selling off their numbers. In Asia and Europe, where they do not have a large block because we developed the internet here in America, in Asia and Europe, a black market is actually developing that we will sell you an IPv4 address for your server. And it's a weird black market. Asia and Europe is now adopting IPv6 because they don't have the IPv4 addresses and they don't want to have to go to the black market. So, IPv6. 1994, they realized that TCP/IP has to evolve. They have to change this. 4.3 billion addresses is just not going to be enough within the next decade or so. In 1995, they started working on IPv6, the next generation of TCP/IP, and a way for these systems to communicate and exchange information and connect reliably and successfully over the internet. 1998, finally, they draft up what they believe what IPv6 should look like and how it should respond over the internet. And that was actually put down in a protocol and said, this is how we feel it should run. These are the protocols it should run as. This is the number. These how the numbers should look and that sort of thing. It was put down by the IETF, Internet Engineering Task Force. And after 1998, everything just kind of sat around. The lethargy set in with a lot of developers. Development of just about any new protocol or any new technology languishes into their force to develop it because research and development cost money. If you don't need it right now, you don't implement it. So that's why it languished. Everybody's like, well, you know what, there's still addresses and this is kind of hard, we don't understand it, so we're not going to really support it right now, we're just going to wait. And we're just going to see what's happened because this is too new. It's now. You need to start implementing it now. 2003, the US government actually looked at this and they said, you know what, we've got a huge number of addresses, we got .gov, we have a huge number of ranges, but we understand and we recognize that we're running out of these addresses. We're going to mandate that all of these departments, Department of Energy, Department of the Interior and that sort of thing, you need to start running an IPv6 backbone, and you need to do it the next couple of years. A lot of departments go, oh my God, how are we going to do this? So they would set up an IPv6 backbone, and they would have everybody else still connecting over IPv4. They essentially said, yes, we've got a backbone, so we met the mandate. However, all the work being done, all the email, all the web activity is still going over IPv4. They're now trying to go back to that and saying, you know what, we're going to try to configure this for the servers so that they do run over IPv6 and whatnot. The mid-2000s, holy cow, we're running out of numbers. This is actually going to happen. So, a little diagram here, how IPv4 works. If you're at home on a router, and just about everybody is, you're probably very familiar with this sort of model. You have your internet cloud, and you have what's called a public IP number. The public IP number is very unique. It's one of those 4.3 billion addresses. And it goes into your DHCP server in your router, and your DHCP server does what they call NAT, Network Address Translation. Takes a look at all the information you're pulling down off the internet, and it translates it into a private IP number, probably something like 192.168, something of that nature, and it takes a look at all the packets. Every single one of those packets going across the wire has a little identifier and a fingerprint on it, using your MAC address, or the unique address, the serial number for your Ethernet card, be it wireless or wired. And it uses that MAC address, that little fingerprint on each packet to say, oh, this has to go to the private IP number for this system, be it your laptop, be it your workstation, be it your file server. So NAT is kind of a cheat. It says, well, you can use a private number, and you can still use this public number. It's still a cheat, and it's a Band-Aid. And it was developed back in the mid-90s because they realized, oh gosh, we're running out of numbers. But this will only get you so far. And it also creates and develops a lot of problems. Has anybody ever set up what they call a service or a server on their home system, where you have like a web server, or you have a file server, or a printer, or something of that nature? Exactly. I see a number of shaking heads. You had to do port forwarding. When a call comes into port 80, I want you to push it over to my web server. Or port 548, it's my file server for my Mac. Or 3389, it needs a remote terminal into my Windows NT box or my Windows 2000 box, that sort of thing. That creates a lot of problems. It creates a lot of headaches for you because you're like, oh God, this is really a pain. So IPv4 really relies heavily on NAT. And it does this because you have classes of IP numbers. A Class A subnet has a huge range of numbers. Class B, not quite so much. We actually run a Class B network at APL. And your Class C is your little private small network, that 192.168 numbers. Usually it's about 255, that sort of thing. So, how IPv6 works. When IPv6 is implemented in your network, you're familiar with, you have a machine running DHCP, or at least I hope you're running DHCP and not a static number. If anybody's smart, they have implemented a DHCP server on their network, and it says, I just attach the system, it gets a number automatically, and I get to the internet, yay. I don't have to manually configure it. For IPv6, it does much the same thing, except it uses something called a RADVID, and that's a router ADV, advertisement daemon. It says, if anybody is going across the wire and it says, hey, I'd like an IPv6 number, the RADVID responds, just like a DHCP server, and it says, sure, here is your information, here's how you should configure, here's your router information on IPv6, here's your IPv6 number, go ahead and develop this. Now, it uses the system gets the information about the network it's supposed to be running for IPv6. But the system itself actually generates its own hexadecimal number. And it does that because it's the only system that really knows its MAC address, or it knows its MAC address best. So the IPv6 number that it generates on its own is going to be tailed off, or on the tail end, it's actually going to have the MAC address on the IPv6 number. Very handy thing because it's a unique number, and it's how IPv6 addresses are able to talk to each other much more effectively. Because the number is completely unique, a clear path is made from one host to the other. You don't have to rely upon port addressing, port forwarding. Oh, if it's running over this UDP port, I need to go to this private number. And it's a way to make a very fast, very secure, very quick connection. Because IPv6 is classless, I was going to put up a picture of like Khloe Kardashian or something up here. It doesn't really need NAT, so you don't need to put up the port forwarding. And IPv6 actually makes 2 to the 128th power of addresses. When I attended a presentation a few years ago about this, the gentleman explained it. He said, that's actually 3.4 undecillion. or 3.4 times 10 to the 36 power addresses. The human body, and I'll give you this little analogy here, the human body has 10 to the 14th power cells in yourself right now. 10 to the 14th power. So we could give an IP address to every single cell in your hand, your foot, your organs, your hair, everything. We could give an IPv6 address to every single cell for you, and do that for every man, woman, and child on the planet living today. And we still have over 50% of the addresses left over in IPv6. So it should hold us for a little while. Yeah, exactly. It's a pretty astounding number. The text is a little small here, but if you read the XKCD comic, essentially the astronauts are stranded on the space station, and someone has actually developed nanobots which do nothing more than convert the Earth into more nanobots. And actually it shows them that, hey, they devoured about 40% of the Earth right now, and then they just stopped. And the reason they stopped is all the nanobots are running IPv6. And that's a pretty clear analogy. You could actually develop or give an IPv6 address to every single grain of sand on every single beach through every continent on the planet, and you'd still have some numbers left over. So it's a very big, huge number. So why is this any better? Well, did I make mention that we have a huge number of numbers? This is, it's 128-bit packets versus 32-bit packets. IPv4 runs in 32-bit packets, so it gives you a good amount of information. IPv6 has 4 times that data, and you can fit 4 times as much into this. Let me give you a little tip. The folks who are looking at IPv6 right now very heavily are 2 main industries, and that's telecommunications, because they really, really, really would like to do VoIP. A 128-bit packet is ideal for sending voice over IP communications. It also makes it really, really easy to give them a number, an IPv6 address. Here, you want to call this person? Hit your quick dial, hit this person, you call them up. So you can do VoIP. The telecommunications industries are looking heavily into this protocol. Also, who's one of the big folks who pushes video over the internet? And I'm willing to bet probably 80% of the people have an account with them. Does anybody know who it is?
Facebook.
Netflix, exactly. I think someone estimated that it's fully like 10 to 15% of all the traffic on the internet right now in America is actually video being pumped out by Netflix. Netflix is actually looking in heavily to IPv6. They've not yet instituted it. They're toying with it right now. Because if they can get this working, wow, video over 128-bit block. That's a lot faster, it's a lot smoother, and everybody wants high definition now. And Blu-ray is kind of being slowly to adopt. My personal opinion is Blu-ray is just kind of dead in the water. Because honestly, if you're getting high def over the wire, you don't have to have the damn disc to throw in there. Why would you get it? So it's a bonus feature. Bonus features, exactly. You know, get the viewpoint. Get Tom Cruise's viewpoint. You know, that sort of thing. I really don't care what he thinks, but anyway.
So what happens when IPv6 is pushing content to you and then you hit your IPv4 network at home?
I'm going to go over that actually in a little bit. So because it's a 128-bit packet, you get a lot more throughput. You got a lot more data pushed out through the wire for every cycle that you're running over your computer. Because it's a clear address from one host down to the other, there's greatly reduced latency. Again, you're not running NAT. You don't have routers exchanging information back and forth. IPv4, when you send it over the wire, it was designed for the Cold War. So if a bomb hits Albuquerque, and you have an internet backbone going through Albuquerque, it's okay because it routes it through Denver, Colorado. IPv4 breaks up that traffic and breaks up the information and tries to scatter it around, and eventually it finds its way to the host over multiple different paths. IPv6 tries to keep itself together a lot better, and it's a much clearer path from host to host. It's much clearer, it's much faster communications. IPsec, IP security, the datagrams, or the data that is actually within your packets in IPv6 is already encrypted and it's already set up for IP security. In IPv4, most of the information is just clear in the text. We're all familiar, or most of us are probably familiar with setting up like an SSL server. You have to set up a cert. It's a bit of a pain. For IPv6, it already has some encryption built into it, so it's already more secure right out of the box. For supported standards and gaining more adoption, most of the operating systems, and I'll go into this in just a little bit, a lot of manufacturers are supporting this because they realize that, hey, we're out of the numbers. We're out of them. They're not coming back. We're not going to generate more. NAT is only a Band-Aid. It's not going to take us in very far into the next century. It's also better world communications if you're running IPv6. Asia does not have a true or does not have a huge amount of IPv6 or IPv4 addresses. Why? Because they've only really come online in the past 20 years. We've been using the internet for the military, for universities and that sort of thing. Europe doesn't have a huge block of IPv4 addresses either. America is right now the slowest adopter of IPv6 because we don't have to do it right this second. But we need to start moving on to it. We need to start advancing. Again, I touched on suited for future uses, VoIP and video. It's ideally suited for pushing high amounts of data, high definition data, over the wire and over the internet. So, what's an IPv6 address look like? Everybody's probably familiar with typing in an IPv4 address. If you want to connect into a server, you want to go to a website, you want to connect to a printer, that sort of thing. You type in your 192.168.xxx number, that sort of thing. It's a simple number that don't go no higher than 255. Everybody's fairly familiar with that. The top line right here, where it has 2001:3A16, you see immediately it's very, very different from an IPv4 address. And I have a sample here. This is off of my XP box at home. You can see, it's probably a little tough, but 192.168.1.120. It's a very simple, easy to remember number. But I don't feel like punching that in because you really should be using DNS. And as a coworker of mine is very fond of saying, DNS is not a fad. Everybody's using it, get used to it. For the IPv6 address up along the top, you can see that it has a hexadecimal number, which is using 1 through 0, and also A, B, C, D, E, F. It's hexadecimal. So automatically you get an extra number of characters that you can use. Instead of using 4 segments or 4 octets, it's actually using 8 segments of the number. Sorry, it looked like the mic took off a little bit. Now, one of the things that's kind of not so great about IPv6 numbers is they are longer, they are a little more difficult to remember, they're a little more difficult to type in, and it offers a lot more capability of you typing in typos or misdoing the address. So they recognized this when they developed it, and they said, well, for the large part of the time, the IPv6 address, which is the full version up along the top, is going to have a lot of zeros in it. So we need a way to make it simpler for administrators and people to implement this. We would like to compound that or contract that number down that makes it a little easier to type, make it a little less typo prone. So if you take a look at the first one, the first line, that's a full address. If you take a look at down the second, you can have a reduction of zeros, and it's perfectly legal in IPv6, that if you have a group of zeros all together, it's fine. Just put 1 0 down together, put 1 0 in there and collapse it. It's fine, it's still a perfectly valid address, and it's still the same address. If you also have a whole string of zeros in the IPv6 address, you can completely collapse that and say, you know what, I'm just going to put a double notation, double colon right there. You can see it 2001:3A16::. That means there's a whole messload of zeros here, but I'm not going to bother to type them all out. Here's my MAC address at the end. And that's the exact same address, notated 3 different ways. Now, if you're saying, oh God, this is a really long address, it's really not so hard. I mean, everybody's capable of typing that last number in, right? It's not so difficult, and it's not too terribly prone to typos. If you take a look at these 2 screens, this is my Mac system at home. This is actually a, I'm a little annoyed to say it, but it's still my Quicksilver box from 2001. Running Leopard. It's a G4 dual 1.8, but it's still grinding away, and it's still running just fine. When I went ahead and told it, yes, support IPv6, this is the address it gave me. Here's my router, here's my address. And you can see right here on my Windows XP box, it gets the same addresses. Okay, so it's using that information, it's able to communicate over both protocols. Does anybody here ever remember using AppleTalk or setting up a machine with both AppleTalk and TCP/IP? Okay, I see a couple of hands. If you remember, I'm probably dating myself, but back in the early 90s, when I started working for a company, we didn't have a TCP/IP connection. Everything ran over AppleTalk because it was great. We had about 100 systems total, and it was zero configuration networking, just plugged it onto the darn wire. We eventually got TCP/IP running, and everything was set up as static, and then we eventually went over to DHCP. It's evolving. But one of the big things that people talked about when they went from AppleTalk to TCP/IP was that they don't communicate, they don't talk to one another. And that's true with IPv4 and IPv6. They don't really talk to one another. It's not really an upgrade. It's a completely different version of the protocol. So you can't have a machine, if you have a machine running IPv4 and another machine running IPv6, they can't really talk to each other. No matter how much you try, they won't talk to each other. They're not compatible protocols. And I'm going to show you how to get around that and work around that. Well, let me go over this first then. So what runs IPv6 right now? Mac OS X has, since Jaguar. 10.2, they have supported IPv6. The Apple routers, such as the Airport Extreme and whatnot, they support IPv6, and they will actually do IPv6 routing for you. They will take the information off the internet and exchange it. Works very, very well. Apple actually upset some folks who are part of the IPv6 community because they introduced a firmware which disabled IPv6. The jury's still out as to why they did this. We think it's a bug going on with the Apple Airport Extreme, but the jury's still out as to whether or not they're going to reintroduce it. Apple's iOS, if you're running an iPad or an iPhone, they didn't immediately support IPv6. It was not until version 4 of iOS that they actually support IPv6 and you're capable of doing it. So if everybody has upgraded their phones or their iPads to probably version 4 or 5, congratulations, you can run IPv6. The Android OS, I don't see a lot of people at the conference with a lot of Android phones. I'm one of the users. But the Android, okay, fellow Android user. Representing. Android has been doing this since version 2, at least, of the Android OS. And the Android version 1, if you ever took a look at it, if you could do a Google search on it, it looks a lot like BlackBerry. The Android OS, when it actually started looking more like iOS, supported IPv6 immediately. So you can actually do IPv6 right over your Android phone. Linux has been supporting it for some time and is supported in just about every single distribution out there. Ubuntu, Red Hat, Yellow Dog, if anybody's still running it, that sort of thing. It is well supported. With Windows, Microsoft, I have to give them some credit. They actually recognized this fairly early, and they actually had a beta IPv6 capability in Windows NT 4 as a development. It was something you had to download and you had to install. And with Windows XP, they actually fully developed the IPv6 stack. So you could throw it onto the machine. And as you saw in the earlier slide, I'm running it just fine on my Windows XP box. Unix and Solaris runs just fine. Hewlett-Packard printers. If anybody has to migrate or has to administrate printers, I'm kind of the printer guru at my facility. HP is really into this, European manufacturer, and they've said, yes, we need to develop and we need to support IPv6, and they have been for about 6 or 7 years now. What doesn't support IPv6 yet? BlackBerry phones. As a coworker has said, or a number of folks have been talking about it, BlackBerry's pretty much dead. They're zombies. They're dead, they just don't know it yet. Because they ran out of addresses. Well, one of the things is BlackBerry has never been really a company that says, hey, we're on the cutting edge, or we see this coming, we're coming down the line. It took them forever to develop a phone which had a camera. It took them forever to develop a phone that had internet. They said, nobody wants to do that, it's just email. That's what we're all about. We do email the best. Email is really not that tough, and everybody's just pretty much flown by them. Now they're trying to do catch-up, but here again, they're probably never going to be able to catch up. So you can't do IPv6 over your BlackBerry. If you have a Nintendo Wii, I'm sorry, you can't do IPv6 yet. Nintendo has been kind of quiet about it. I'm actually very interested in doing this because I run IPv6 at home, and I have Netflix running over my Wii, and I would very much like to have the videos look a lot better, but alas, it doesn't work. Xbox doesn't support it either. My son got a PlayStation 3 this past fall. It doesn't support it either. So I was all excited. I put the Netflix client on the PS3. Nope, no IPv6 support. Dang it. So no IPv6 support there. So who's offering IPv6 right now? If you're in Comcast, there is some good news. They are starting to offer support in a select few areas, and they will give you an IPv4 number as well as an IPv6 number, with a little caveat. Just about everybody here is running a router, right? And the reason you're running a router is because you don't have just one system hooked up to the internet, right? Everybody's nodding. Comcast has said, yeah, we'll give you an IPv6 address. A IPv6 address, just one. To me, that is a huge kludge, is a pain in the tuchus. Why in God's name would you just give people one IPv6 address? Because nobody has just one system sitting at their house anymore. That's the whole point of running a router. And Comcast essentially puts it as a feather in the hat, like, yeah, we have IPv6 support. We'll give you one address. You've got a boatload. Why don't you give me a few more? But they won't do it right now. The later support may change in the next few years. Verizon, if you're running a DSL, nope. They have no immediate plans. There are some rumors that they have done some testing with some of their employees, with some of their home hookups and that sort of thing, but they offer it nowhere in any of their DSL service. If you're running Cox Communications, which are fairly popular around the DC, Virginia area, there are some limited trials. They're actually using a tunneling technique called 624. What that means is you have a machine that's running both IPv6 and IP version 4. And since it can communicate over both protocols, it can move the information and exchange the information between two different clients. For AT&T, they're right now trying to do an upgrade mode. And they are using some 6 in 4, and that's a tunneling technique I'll go into in just a little bit. For their DSL service, they are offering it for some limited areas. Again, it's kind of slow. Time Warner Cable, which I had to do a lookup in Pennsylvania, apparently this is a big ISP in this area. Time Warner is preparing, they're announcing that they may do some trials sometime this spring, probably this summer. If you're lucky enough to have Quest Communications, and some folks do at their facilities, if you have a very large like university, that sort of thing, Quest is actually offering a dual stack communication, which says, yes, you can run IPv4, you can run IPv6, it's fine. We'll give you an unlimited amount of numbers. Really great ISP, but they cost a boatload of money. So if you're not rich and you can't afford, not you rich, but if you're not, if you're not rich, right, I'm sorry, if you're not rich and you can't afford Quest Communications, there is a way to get around this. Let me see if I can click through here. Okay, so I'm stuck waiting on my ISP. Well, yes and no. If you want full dual stack support, yeah, you're going to have to wait on your ISP for your internet provider. Dual stack is absolutely positively the preferred way to go. It means we will offer you a connection over IPv4, we will offer you a connection over IPv6. You can use both protocols, everything's wonderful, and great, you're running both protocols, so you're ready for the future, you're ready to go. However, if your ISP is not running that, you can do what's called a tunnel technique. And tunneling means you run IPv6 at home, and you can fragment it and actually embed it in the UDP of the IPv4 packet. It goes over to another firm, which does have a connection over to the IPv6 internet, and allows you to still talk to the internet running IPv6. So there's a number of different techniques. There's one called Teredo. Moredo is the Unix name. 6 to 4, 6 and 4, 6 over 4, and the list goes on and on. It's a bunch of different tunneling techniques. But it's still just a cheat. But there is a way to get your feet wet in the new protocol, how you can run this at home. And when you get home, I'll show you how you can do this. So I'm going to show you how to make an IPv6 tunnel at home. And it's very quick, very easy. You won't need a pickaxe. You won't need a shovel. It's two great big tools that you're going to need to make this happen. Has anybody ever heard of DDWRT? DD-Word. Okay, Rich has heard of it. It's a replacement firmware for a boatload of low-grade or mid-grade consumer-based routers. Stuff you can go down to your Staples, your Best Buy, whomever you buy your router from, and you can flash the darn router. DDWRT is available for hundreds, thousands of routers. Go take a look at them. You'll need also a tunnel broker. Mine of choice was Hurricane Electric. There's also a few other ones called GoGo V6 or GoGo Free 6. But before you make any changes, make sure you record all your settings. If you're prepared and you're willing to do a little experimentation, you can get this running. But please record all of the information that you have on your router now before you get started. That includes your port forwarding for your UDP, your settings, your host name, that sort of information. You can't just import that information back. So once you start, again, there's no going back. In case you're not familiar with the Shawshank Redemption, when Andy got out of the cell, so that's making your tunnel. Okay, so getting your hardware ready. take a really hard look at your router. Flip it over, take a look at the product number. Also take particular attention to the version number. The version is very important. A manufacturer will go through umpteen incarnations of a router. Linksys is very famous. If anybody has ever run a WRT54G, which I've run at one point, just about everybody has, an extraordinarily popular router. They also made about a dozen different versions of them. The dozen different versions had different amount of RAM on them, had a different amount of flash memory, had a different processor, different versions of the processor, different boards, and that sort of thing. DDWRT supports a few of those, but not all the versions. So pay particular attention to your router and make sure you have the right version number. Next, pay a visit to DDWRT or DDWRT. Take a look at their router database, and if you've got a connection, you can do this right now. You may know the exact number or version of the router that you're running at your home for your home setup. Take a look at their router database. When you take a look at the router, and I've just popped in here, which I happen to have ready, a Linksys WRT 160N, it was a version 3, and they said, yes, we've got several builds available. Here, you can download any of these. When you go there, make sure you grab this information off on the right-hand side. It will give you some quick how-tos, some FAQs on how to do this successfully. For the love of Pete, don't make a brick. There's enough waste or enough e-waste in the world. You don't want to have a router that just sits there and does absolutely nothing but power and some lights and can't do a damn thing. So avoid making a brick. There we go. So once you've got your DDWRT, you've got your replacement firmware, you've read all the instructions, and you've prepared to do this right, you're going to have to flash your router. This was an actual page off of a router that I had just laying around. It's a WRT 160N. And right over the GUI interface, I've told it, I want you to flash with the DDWRT firmware. So go ahead and flash your router and be prepared to wait 5, 10, even 15 minutes. But be prepared to wait. It won't hurt you to take a few minutes to get it done. After you're confident that you have waited a good time, 5, 10, 15 minutes, and that's pretty good, unplug the router, plug it back in. Give it a few minutes to boot up. Try to go to its initial IP address, which is usually 192.168.2.1 or 1.1. You'll see this firmware, and it's the DDWRT firmware on your router. Your router is now a brand new router. It may have cost you 50 or 60 bucks. It's now probably worth about $600, or at least the features are worth $600 because it has some professional grade capabilities and some professional grade tools built into DDWRT. And the best thing about this is, again, it's all free. You can download this right now off the internet. When you're done doing the flash, the creator and the designer of DDWRT heavily suggest doing what they call a 30-30-30. 30-30-30 means grab your pen, push in that damn reset button. Hold it in for 30 seconds while your router's still plugged in. You'll see it do a whole bunch of flashing lights. Count down 30 or 35 seconds. Unplug the router. Keep the pen pushed in. Again, do a countdown for 30 seconds. Plug the router back in. Again, wait 30 seconds. This is his technique for making sure you blow away every single possible setting that could be in the NVRAM of the router. He said, I can't tell you how many times people have sent me emails or sent me problems like this isn't working or something's not working right, something's not stable, blah, 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 blah. And he's basically asked them, did you reset everything? Well, no, it just kind of worked. I'm like, well, no, do the reset and try to get this working again for you. Okay, once you've got your router set up on DDWRT, I highly recommend take a look at those settings that you recorded before you flashed it. Get everything working properly over IPv4 again, making sure your initial setup is working good and you've got a good connection to the internet. I used Hurricane Electric. Again, you can use any broker you like, but I'm showing you how to do this on Hurricane Electric. It worked for me. It will almost certainly work for you as well. So pay a visit to he.com. Sign up for their free tunnel broker setup. And I have the link right down here at tunnelbroker.net, and you can click on the link right from there, IPv6 tunnel broker. So you click on that link. From here, you can create your own tunnel. And you can see right now for this screenshot, you have to choose a server or a tunnel broker which is near you. And Hurricane Electric has them scattered throughout the United States and Canada. So it would behoove you to choose one that's near to you so that you don't have to go through a lot of routers or a lot of router hops. So choose one. When you eventually find that this is working, there are two things which Hurricane Electric require you to be. One, you have to have a live IPv4 connection to the internet. You probably already have that. Two, they have to be able to ping your public IP number. So if you're running something that's like in a hotel or your university and they're already running that, this isn't going to work for you. You have to be running a public number, and they have to be able to ping that number because they don't want people just setting up tunnels willy-nilly. Oh, well, this didn't work, this didn't happen. So if you do have a public number and they can ping it, and a lot of routers will block a WAN ping request, make sure it's turned on and it's available. You'll get this little information. IP is a potential tunnel endpoint. Congratulations, we're going to go ahead and give you a tunnel. At that point, grab this text, grab this information. And forgive me, I blocked out mine from when I set up my tunnel. Grab your user ID, grab your tunnel information, grab your server address, grab all this information, print it out, do some screen snapshots. You're going to need it. And if you actually do a copy-paste, you're going to actually put it into a small script. This presentation, as well as just about all the other presentations at the conference this week, are going to be posted online. So if you want to do a snapshot or write this down, this is where you can download the script. It's about a full 2-3 pages. You don't have to edit the whole thing, only about 6 lines. But this is the link to the script. So if you want to jot that down, I'll give you a few moments. This script was not developed by me. It was developed by somebody who's much, much smarter than me and much more adept at Unix and Linux and that sort of thing, and is very familiar with DDWRT and Hurricane Electric. What the script does is it actually sets up a RADVID, a router advertisement daemon, on DDWRT. It checks in with Hurricane Electric, says, hey, I'm live, get the tunnel working. Gives it its public IPv4 number, and Hurricane Electric says, here's the segment that I want you to run on your side of the tunnel. And DDWRT in this script takes care of all of that for you. It's a minimum of work. You just edit 6 lines and paste it into the router to basically tell the router, when you boot up, run this script. Once you've got that, it will go ahead and set up the tunnel for you and advertise an IPv6 address capability across your LAN. So your laptop, your iPad, your iPhone, whatever you have, if it has IPv6 enabled, bing, it gets the number. Congratulations, you're on the IPv6 network. Couple little things that I have noticed with DDWRT. If you're running a wireless router and it's your endpoint, I have noticed that the timing for the wireless is a little weird. It's sometimes a little unstable. I would highly recommend set the wireless timing to 0. This basically forces a device to take a look at make a connection very, very quickly. If the timing is set for that, it tends to time out, and eventually the air card or the wireless card just dies, and it doesn't want to offer wireless access. If you set it to 0, it doesn't affect anything other than if your device is really, really slow or really, really old, it may take a couple of tries to actually attach to the wireless network, but it makes your router uber stable. One of the nice things about DDWRT that I have set up is I tell the router, I want you to restart yourself 4 o'clock every single morning. My wife doesn't worry about the internet at the house, and the reason she doesn't worry about it is because it's always on, it's always available. And one of the nice things about it is because it restarts itself every 24 hours. I haven't reset my router since September, and that was when we had a thunderstorm. So it makes it very, very quick, very, very easy. A couple other things, again, on that page, you'll see, go ahead and enable your IPv6 settings, reboot the router, and check for IPv6. When you're done with this, you can check on your system and see if you've got an IPv6 number. If it's working properly, you can go to this website, testipv6.com, and it will tell you how good or how well your v6 connection is working onto the internet. You can also do another website. Is anybody familiar with IP Chicken or What Is My IP? Okay, you're probably familiar with that. It's a very clever tool which people use to say, okay, what's the public number for this network? What number am I using on the internet? There's another website, whatismyv6.com. And it will tell you if you're running IPv6 or if you're communicating. It will also tell you if your browser prefers to run over IPv4 or if it prefers to run over IPv6 and what it does if it has both available. It should try to use IPv6 if both are available. Not all browsers do it. So you can do that as well. Okay, so provided you've got DDWRT flashed on your new router and it's working properly, you've got your setup script and you've got your tunnel working very, very well, terrific. What the hell do I do with it now? Well, you can go to V6 only pages, www.v6.facebook.com. Facebook, it prides itself in that it's never down. If you've ever watched, what was the movie, The Social Network? Remember, his guiding principle was the website can never, ever, ever be down. If it's ever down, they will start leaving. And they've never really been down. At least no one's ever caught them ever being down. They were one of the first folks to say, we need to start supporting this. Because there's a boatload of people in Asia, there's a boatload of people in Europe who are running IPv6. We need to make this available to them. That's a whole new market that can open up to us. So they're one of the very first early adopters. And they've set this up a few years ago for what they called IPv6 Day, which was test your IPv6 communications on your local network, see if you're actually going to be able to communicate with the rest of the world when people and host websites have to go over to IPv6. I'm not going to ask for a show of hands, but if anybody here has ever run a BitTorrent client, say like transmission, amazingly, when I've heard it rumored that if you run transmission on your Mac and you're downloading something, you get a boatload of people exchanging and doing bits over that torrent from Asia and Europe. And you can see people communicating with you over IPv6. Transmission fully supports it. It's kind of interesting to watch because I've heard this again. In transmission, it actually pops up a little flag that says the country that the IPv6 is originating from, and it tells you exactly where you're downloading or you're uploading to. It's kind of neat. So, and you can also do a test. IPv6 Day this year is June the 6th, 2012. So they're just going to beat the Mayan calendar apocalypse. Congratulations. So if you're ready. Now, as time goes by, adoption of IPv6 is going to gain momentum. Again, the numbers were exhausted last February, or February before last. It's over. You're going to have to start familiarizing yourself with it now. Begin making plans. Start getting your network ready. Start getting the hardware ready. Start getting your operating systems ready. Contact your vendors about IPv6. We use a remote product called BombGuard. I don't know if anybody else here has used it before. Okay. Rich used it. Very intelligent guy. I like him already. He's running BombGuard. I brought BombGuard into our facility. They just introduced IPv6 support. I'm excited about it. My management, not so much, but I'm excited about it. There's also a great book. Here's the ISBN numbers. If you go to Amazon or any of your popular Barnes & Nobles, any popular website, it's an absolute fantastic book. It will allow you to read up about IPv6 and get more familiar with the protocol. Take the time now to get familiar with it. You're going to have to use it eventually. In 10 years' time, everybody's going to be like, oh, yeah, we did that a while back. So those are the numbers. Grab the book. It's a big world out there. So get ready for IPv6. Oh, one last thing. Since Steve Jobs is dead, I'll start it up again. Is anybody interested in doing a little experiment at home? Raise your hands. 1, 2, 3. Okay. If I could ask you to all stand up. Just real quick. It won't hurt, I promise. Okay.
Quick, shoot him!
Okay. Does anybody remember, there's two ways I'm going to do this. Does anybody remember the number, the theoretical number of IPv6 addresses, which I listed?
4.3 billion addresses.
That's IPv4, but IPv6, the theoretical number. Does anybody remember?
I do.
Just stand up. Do you?
2 to the 128.
That's right, exactly. 3.4 undecillion. Okay, stand up. Okay, so he's got it. He's the only one who remembered. Okay. You get the mystery box. I know.
I didn't bring you anything.
No, I'm sorry. There's jelly bellies out in the back. You can pass it along.
Thank you, Penn.
The mystery box happens to be a Linksys WRT. Yeah, you can open it up. It's a brand new WRT 160N. It is running the DDWRT firmware.
Look under your chair.
Okay, this isn't Oprah. But anyway, you've got a brand new wireless N router. It already has DDWRT flashed on it. It has the login information. By all means, use the information you've learned here. Get an IPv6 tunnel running at your home.
Awesome, thank you.
You're quite welcome. That concludes my presentation. Does anyone have any questions? Yes?
So, if we decide to set up this at home, I've got an ASA 5505 at home.
Okay.
Which I believe has full support for IPv6.
Okay.
I have Time Warner Cable as my provider. If outside network?
You mean on your LAN? So you're like your wife's laptop, your kids' iPads, or iPods or whatever, they're running IPv6. That's the nice thing about when you set up this DDWRT router, it says, hey, I'm going to handle all of the IPv6 for you. You don't have to do anything special about it. The tunnel is advertising IPv6 addresses on your LAN, on your interior. When I set this up, I didn't have to do a damn thing because I had not disabled. The last lecturer who was in this room said, oh yeah, here's the terminal command for disabling IPv6, and I groaned. I understand that it's not used a lot now, but it will in the future. When you get this set up, or if you set it up successfully, fine. Your iPad, your iPod touches, your iPhone, or whatever, if they connect into the wireless LAN, boom, they get an IPv6 address. You don't have to do anything weird. You don't have to do anything funny. You don't have to run any terminal commands. Nothing. It just works. When I set this up, I immediately tested every single device around the house. The kids' iPods, the wife's MacBook, my MacBook Pro, my XP machine, my Windows Server 2000, my Mac 5500 that I was running. Everything worked except for the Mac 5500 because it was running OS 9. And my BlackBerry, which is now gone and dead and buried.
So what do you do about those devices, like embedded Blu-ray player, game consoles?
You can check. If you're not sure if it's actually working or if it's getting an IPv6 number, you can go to www.testipv6 or whatismyv6.com and you can check. It'll have it right there. It's like, yes, you're running IPv6. Here's the number you're communicating with and you're running this successfully. And the last thing is, can you actually connect to IPv6 DNS servers? If you go to that site, test IPv6, if you're doing everything else but the IPv6 DNS, it'll give you an 8 out of 10. That script that I showed you that you can download from DDWRT's website actually sets up the DNS v6 servers for you, so you don't have to do that either. So it gives you a 10 out of 10 rating on testipv6.com. And again, they're both free. Yes?
So with NAT, you kind of were protecting your network in the sense that you had one public IP. If you go to IPv6, is that now mean that all of your devices are publicly routable and you should
Yes.
firewall each device?
Yes, that's something I did not, that's something I actually failed to cover. When you set this tunnel up, you essentially have a full-on connection to the internet. So double check with your vendor, Mac OS, Windows 7, Windows XP, and that sort of thing. They do have firewall capability over IPv6. Sometimes they don't. If it's an older service pack and that sort of thing. When you're running this, remember, you've got a full-on connection to the internet. So be cautious, be wary. This is why I don't suggest doing it for your enterprise yet. You know, wait until you get something else running. Yes?
You mentioned that IPv6 has some encryption options.
Yes.
By default, are they turned on, or is it like SSL where you need to go, when you go to a particular site, it'll trigger those particular encryption options?
It already has IPv6 built, IPsec, I'm sorry, built into IPv6. So it is encrypting it. It's already doing some basic encryption, so it's not in the clear. It's not doing full like PGP or Entrust. It won't do that level of encryption, but it's not doing something in the clear.
So like,
Exactly, the packets are not
so
in the
if
clear.
you're sending FTP traffic back and forth, that's not going in the clear if you're using IPv6.
That's right.
Okay.
That's one of the questions, yes.
Do you really get any gain in efficiency if everything's being, when you're doing tunneling, if everything's being bottlenecked at IP4 level anyway?
Not as much as if we were running a dual stack. Again, the tunnel is a cheat. The tunnel is taking the IPv6 and it's encapsulating it within the IPv4 packets. Now, it does help because your latency is reduced. Now, the speed improvement is not very robust as if you were running dual stack. If you're running dual stack, wow, everything's just flying across. Adam Sawyer right over here, he actually runs a lab at our facility. And they have set up a DHCP v6, DHCP or RADVID server. They're running IPv6. The throughput on his wires, which is purely internal, is through the roof. It runs extremely fast. For the tunneling, no, you won't see a vast speed improvement. But what you will see is a reduce in latency. Because the IPv6, like say you're watching a movie from Netflix. Netflix goes to Hurricane Electric, which is a full-on fast connection. Hurricane Electric says, okay, I know I have to go to this router, your DDWRT router, and it throws the information down. Now from that point, once it goes internally, then it pushes the information onto your local device. So it's not going to be as pronounced when you're running the tunnel. And that's one of the drawbacks of running a tunnel. It's not a solution, it's a Band-Aid of how you can get your feet wet in the new protocol.
Yeah, I understood that.
Yeah.
I'm on a real high latency rural Wi-Fi ISP, so I'll try to help.
Yeah.
Just because I should be able to notice the latency difference.
Yeah. And again, if you're lucky enough to have a router that does run DDWRT, it's free firmware. You can throw in the thing. The script is free. Hurricane Electric is absolutely free. There's no reason not to try it. Even if you're like, well, this isn't for me, just flash your router with DDWRT. It's a much better piece of firmware. It runs much, much better than Linksys or just about anybody else. Yes?
DDWRT, it doesn't filter the tunnel then?
No, it doesn't. No, it doesn't do any tunneling. It's not a NAT6. NAT6 is actually a service and capability being developed as we speak, because they recognize the fact that, oh, this creates a problem for security, where your machine has a full-on connection to the internet. They're working on NAT6 to try to reduce that presence on the internet and say, you know what, I'm going to have something which is going to do a little bit of filtering. But DDWRT doesn't do that. It just handles the connection for you. It would be much like setting up, it's like setting up several DMZ ports, you know, if you're familiar with that, okay? Any machine that's running IPv6, congratulations, you're now a DMZ. You know. Anything else? Yes?
Well, I have two things I wanted to add in the question for you. About the address, having your MAC address in there. I think that, I'm not sure if macOS 10 has it on by default, but I know that Windows 7 does the privacy extensions for IPv6, which kind of uses a pseudo MAC address, if you will, not your actual machine's MAC address to generate your address, so that kind of covers you from that sense that your MAC address isn't being displayed publicly on the internet.
Yes.
And I was also just reading recently, because I was doing a report on this for our department as well, that the IPsec support in IPv6 is now, by the standards committee, made optional, so that you don't have to implement that if you implement IPv6, even though that was the initial goal.
Right.
Which is a little bit concerning. But, and then the question I had was that, are you, for the next IPv6 day, is your organization planning on doing anything like public for, we're going to try and make our website IPv6 accessible and a couple of our services as well. But
Unfortunately, I'm part of the Mac team at our facility at APL, and we essentially manage the desktop Macs. And you know, as my friend Eric puts it, our job is to make the Macs suck as little as possible. At least, you know, the Windows machines are already bad enough, you know, and we're trying to make, you know, there's a reason everybody has gone.
Macs just don't suck.
Yes, their Macs don't suck. There's a completely different group that works with the internet connectivity, and we're not part of that group. I'm actually friends with one of the people that is part of that group. He has actually set up a tunnel to guess who? Hurricane Electric. And he has us running in just his building and only in his building because he doesn't want anybody to know that he's running it. And the reason being is security would have kittens if they knew he was doing this. Oh, I probably shouldn't be talking about this.
Something kind of recorded.
Right, something like that. They're going to edit that out, like on Conan.
we have Cogent and Level 3 as two of our providers, and both of them have provided us with IPv6 blocks, so we're ready to go there. It's just a matter of other devices on the network.
Yeah. Well, I mean, to answer your question, you know, no, we're not planning on a big to-do for that. For my facility, for APL, they're not really pushing this very hard. I'm actually one of the very few people at the facility who's trying to kind of light a fire under management and say, you know, we need to do this. I'll give you a great real-world example. We just set up a brand new, huge building. It is, I think, the tallest building in all of Howard County, Maryland. And the reason that building itself is now running NAT. They're all running private IP numbers. And why? APL ran out of numbers. So, you know, I basically pointed out to them, the reason you're running out of numbers is because there are no more. You're not going to get any more. So they had to go to NAT for a complete building, and now they're having to do it, flush it over, and spin it off to other buildings. So they're running NAT. It's like, it's just a Band-Aid. At some point, we need to do this anyway. Yes?
I feel dumb that I don't know the answer to this, but
Don't.
are there still ports in IPv6?
You mean like UDP ports?
Like port 80, port 12, port 3,
Yes.
Okay, so there's still ports.
There's still ports, yes.
So, so when you do a web address, colon, the port, get to it, all that, still works the same.
Yeah. Yeah, and it runs, it's very similar to IPv4, but it's not IPv4. It's set up, they use IPv4 as sort of the baseline to develop it, and the whole reason being is we want security to be better, because they developed this back in the 1970s. IPv4 was developed in the 70s. This was developed in the 1990s. It's a full 20 years later, lessons learned. They took what they learned from IPv4, some of the problems, some of the benefits, and that sort of thing, and they applied it to IPv6. So yes, there are ports in there, but they're... Right. TCP/IP is still TCP/IP, and UDP is UDP. So, anything else? Thank you very much for your time, and enjoy the rest of the conference.